Okay, we'll go ahead and get started. There's a couple of seats up front if anybody wants to move forward a little bit to make room for folks coming in the back. I'd like to thank everybody for coming to the first of the sessions at Build this year following this morning's keynote. I appreciate you guys spending the next 60 minutes with me, and we'll make it worthwhile. Today we're going to talk about integrating HDInsight with your Azure applications. And so, quick show of hands, how many folks are writing apps in Azure today? Okay, great. How many folks are writing apps in a cloud that is not Azure today? It's okay too. How many folks are using HDInsight? Okay, cool. Thank you very much. How many folks are using Hadoop in some form or another? Okay. How many folks have played with Hadoop but aren't using it? Okay, a few more folks. Cool. Well, my name's Matt Winkler. I'm a program manager on the HDInsight team. I've been on the team for the last 2 years as we've gone on a little bit of a journey to bring Hadoop into Azure. And we've GA'd the service in October, and this is kind of the first chance we've had to come and give a little bit of an update on where we're at, as well as talk about what is the service, what are the scenarios that we're seeing with customers, and then I'd like to dive into tips and tricks for enabling those key scenarios. I won't be writing a whole lot of code in the talk. I've got a bunch of code on the slides, and I'll make those available after the talk. Two things we really won't dive into today. We're not going to dive into a Hadoop tutorial. More than half the room said they've played with Hadoop, so we won't be diving too far down that path. We'll show a bunch of Hadoop stuff, but it won't be a Hadoop 101 conversation. And then we won't dive too deep into the Hadoop 2 feature set, which we recently GA'd in the service. There's a session on Friday where I'll be talking about that, and so we'll spend the whole session on Friday diving into Hadoop 2. So what is HDInsight? HDInsight is Microsoft's offering inside of Azure for creating, managing, and running Hadoop clusters. The nice thing about the cloud that it brings to the Hadoop equation is really, you don't usually do a lot with a small Hadoop cluster. Most folks use a fairly sizable cluster. And so the amount of money you have to spend to just get a cluster can be pretty prohibitive. The nice thing about the cloud is that it really plays very cleanly there to be able to walk up and say, hey, I'd like 400 nodes, and in 10 minutes or so have that up and running, run it for 15 minutes or an hour or 2 hours, tear it down, and then you're done. That's a much more cost-effective way. We really want to make Hadoop a lot simpler to use. And where we've started on that is really around the experience of obtaining a Hadoop cluster. It's about 3 clicks, 4 or 5 text boxes, and then you're off to the races with Hadoop. The other thing that we're doing that's pretty interesting in the cloud is that we're built on top of Azure Storage. And what that means is we rely on Azure Storage for being your long-term persistent storage mechanism. And what that means is that your Hadoop cluster can become completely transient at that point. And so for those scenarios where I don't need to run a 500-node cluster 24 hours a day, 7 days a week, this is super, super compelling. If you want to run a 500-node cluster 24 hours a day and 7 days a week, I am completely fine with that. Please, go right ahead. But HDInsight sits on top of blob store. And so the other thing that's nice about that is for all of the features that the blob storage team delivers, say geo-redundancy, that allows you to have a Hadoop solution that leverages that as well. And so we don't need to figure out how to do disaster recovery for your Hadoop cluster. That's been figured out at the storage layer underneath us. And so that means you don't have to figure out how to solve disaster recovery for Hadoop, which on-prem can be a fairly costly thing if you're talking about replicating a 500-node cluster in another data center. So what is Hadoop? Hadoop is now an umbrella term for a collection of open source projects that are all about processing big data. It's really where most of the industry is at. In terms of if you want to go and do big data processing, you're going to use Hadoop. And so Hadoop started out as open source implementations of 2 papers from Google, the MapReduce paper and the Google File System paper. And since then, it has really exploded into an entire ecosystem of a bunch of things that have funny names: Scoop, Uzi, Mahout, Giraffe that's spelled with a PH. And all of these things are open source solutions that solve various different problems. It could be machine learning, it could be graph processing, but it brings those capabilities so that you just keep adding value into the Hadoop ecosystem. And so what we've decided to do at Microsoft is really ride that wave and embrace that, put that inside of Azure. One thing to call out, a trite description of Hadoop is that it is a distributed system for counting words. The canonical hello world for Hadoop is word count. And so you'll see, as you dive through most of Hadoop stuff, it's hard to go too far without running into some example that counts words. Let's go ahead and flip over to a demo. And so what I'll be showing today, this up here, okay. So this is the portal. Everybody who's got an Azure subscription today could follow along at home if you'd like. And what we'll do here is first we'll go ahead and create a cluster, and then we'll show what the experience is for using a cluster. So just like other things inside of Azure, you've got a couple of choices here, quick create or custom create. So quick create is really the simplest way to get up and running with Hadoop, and you need to provide 4 pieces of information here. What do you want your cluster to be called? How big of a cluster would you like? What's the password for accessing the cluster? And then what storage account do you want it associated with? This is going to determine data center placement. But if I fill these fields out, type this in, and say go, in about 10 minutes I'll have a cluster up and running. Okay. Sorry, IE has decided to not be particularly happy with me right now. So we'll refresh that really quick. The other thing that we can do outside of quick create is we can go and do the custom create path. And this is where we follow the same pattern as the rest of Azure, but really this, you think about a set of stops on the spectrum of complexity. With custom create, we start to give you a few more options, right? And with custom create, I can specify not only the size of the cluster beyond what's just in that dropdown. So we'll go ahead and switch back to slides. The internet connection's been a little flaky for my laptop today. But so what custom create will allow you to do is go beyond the 32 nodes that show up in the dropdown. That 32 nodes is not a hard limit of the system. It's simply the limit that's in place for somebody who wants to walk up and just create a cluster and play around with it. If you get beyond 32, people tend to call us and are a little surprised about the size of their bill at the end of the month. So custom create will let you go in, and that will allow you to create a cluster for as much quota as you have. I've got clusters that are up and running that are in the 100 node range. We can create clusters larger than that. We have customers who are working on multi-100 node clusters today. The other thing that we can do there is we can provide a custom metadata store. And this really helps with that transient cluster pattern. And what that means is the metadata store is responsible for remembering, hey, inside of Hive, I have these 25 tables that have these columns that are stored in these files. And so by attaching that metadata store, you can basically pick up your cluster from where you left off. When you dropped your cluster the last time, it's like you never left. All of your tables are there. You can still do select right from that table and get up and running. So through custom create, you can also specify that. The other thing that we can do there is attach multiple storage accounts. So for a number of reasons, folks will have more than one storage account. It may be they have more data than fits in one. It may be that they're sharding across storage accounts so that they can get above the I/O throttles that are on the storage account. And so you can attach up to 7 storage accounts inside custom create. Again, that's not a hard limit on the system. It's just the wizard starts to look really silly if we put 7 things off to the right-hand side. The next level up in terms of sophistication or complexity of cluster creation is really dropping down to the API layer, right? So everything behind the Azure portal is a REST API that we've got clients on top of. And so either from PowerShell or the cross-platform CLI, this is where you can do everything. You can specify size, you can specify metastores, you can specify as many storage accounts as you want, up to 70. So there is a limit right now of 70. If you need more than 70 storage accounts, please come talk. I'd like to learn a little bit more about that. The other thing that you can do that's interesting in the PowerShell case is that you can provide custom deployment and configuration information for the cluster. So I can say, hey, I know I need to tune my Hadoop cluster to have these various config values. I can set those inside PowerShell. I can also say, hey, I would like to deploy these jars of custom UDFs or other Hadoop projects. I want to deploy those to my cluster. And so from PowerShell, you can go ahead and do that and say, hey, I want, on every node of my cluster, I want to make sure that this jar is in the class path, because I've got some custom bit of logic that I've written that I'm exposing there. And so that's really the spectrum of options that you have around creating a cluster. The next step is using the cluster. Let's see if the network is being a little more friendly for me. And we've really got two interfaces for using the cluster. The first is through PowerShell. And so this is super useful for a scripting experience when I want to put together a number of HDInsight jobs. And so any type of job that you'd like to run, whether that's Pig or Hive or MapReduce or Scoop or MapReduce streaming, you can submit that job via PowerShell. And then when that job is finished, you can use the wait job commandlet to wait until that one's done. You can then schedule another job, and so you can build these into pipelines. The nice thing about this is that it lets you build up and automate that cluster creation, run a job, tear down your cluster process. So if you want to run every night at midnight and process over all the log files that got generated in a day, we can all sit down and write that PowerShell script, create the cluster, run the jobs, and then just schedule that using whatever scheduling mechanism you'd like to use in order to automate that workflow. And the nice thing about the pricing model is that we bill per minute. So you're only going to get charged for how long that query runs if you do it that way. So we've gotten a bunch of feedback about the PowerShell commandlets. Folks are okay using them, but they'd like a friendlier interface for using the cluster. And so one of the things that we'll be doing later in April is we will have a Hive editor that's on the cluster. And so what you'll be able to do is navigate to the cluster. You'll be able to get a Hive editor there, submit your jobs, see your job history, as well as be able to browse the file system for folks who are not super enthralled with interactive query through PowerShell. So we'll do that. And then the final option that you have is the ability to RDP into the cluster. And so RDP is turned off by default. You can opt into that via the portal. You can say, I'd like to turn that on. Here's my username and password. And then you can RDP into the cluster. This lets you use all of the familiar Hadoop tools. So if I want to get a Hadoop command line and write Hive queries, I can go ahead and do that. And so this will give me the most fidelity with all of the samples that I find about run this Hive command line, run this Hadoop command line. What we see folks doing is going here, using this as a development environment, and then automating and operationalizing their workflows outside the cluster. An important thing to note here is you can make a lot of changes to the cluster this way. Those changes are not guaranteed to be preserved. So just a little bit of a warning label. If you go and change a lot of config files here, it is possible that the machine could get reimaged at some point in time when we service the cluster. And so that's why it's fine for a development environment, but it's really something that you want to operationalize into the scripts that you've got outside the cluster. Because that's what that will do is that will ensure that the changes and configurations you make to the cluster are durable. So let's talk a little bit about customer scenarios. I've got 3 slides that the marketing team put together that I won't spend too much time on, but I think they point to case studies that we've published, and I think they're all fairly interesting. The first one is about a retail chain of dessert and beverage shops throughout Malaysia. And they're kind of the classic example of I've got a whole lot of distributed locations that are pumping data up into the cloud, and I want to make sense of that data. And so really what they're processing there is they're taking all of the data that's coming out of their point of sale systems, and they're analyzing that and they're mashing that up with the corporate data that they've got as well in order to do interesting analytics. And really what they're trying to do is just understand and predict customer behavior. Second one that we'll talk about is Hansen. So they are an ingredient manufacturer for the food and pharmaceutical industries. And these guys really are really kind of emblematic of that Internet of Things scenario that I have lots of sensors distributed throughout my factory. And what they're doing, one of the reasons they like HDInsight is that they're able to spin up clusters on demand for ad hoc analytics. And so they're logging all of this data up into the cloud, and they're able to spin up a cluster pretty quickly when someone says, hey, I have this theory and I want to play around with the data. Oftentimes you go through this journey of someone will play around on a very small set of data, and then you can do that in Excel or R or any number of tools locally. And then you want to take that and you want to say, okay, I've got a much larger set of data. Let me go try and prove that out on the bigger set. The final one, this one's kind of cool, is Halo. And so what Halo is doing is really 2 or 3 different things that all revolve around in-game telemetry. So if we think about all of the Xboxes that maybe a couple of folks in the room have that we're playing that are emitting telemetry data, that's all landing inside of Azure. And so what the Halo folks have done has gone on this journey of first, they wanted to just understand player behavior. What's going on? How can I make sense of things? What maps are popular? And then they started to get smarter about the data that they had, and they started asking deeper questions. Hey, what's wrong with this map? Why is it that this map is intrinsically unfair? Because there's this spot where almost always the other team is killing all my guys when we're doing this multiplayer game. Then they said, as they went a little further, so they started tweaking the gameplay based on the data that they were getting out of the system and the analytics that they were running. After that, they then started saying, hey, we can start to find some interesting patterns. And so they started to use all of this telemetry to start to push on, how do I identify players that are cheating within the game? Folks who have illegal mods or things like that. And then where they've ended up is they're now using it in conjunction with marketing campaigns in order to figure out, hey, we know that 3 out of the 4 times you selected this weapon, so the next time we send you a piece of mail, we know we will include that. And so the Halo folks have gone on a really nice journey of starting off with some fairly basic data that they were collecting that's now powering lots of different pieces and parts of that business. So a lot of times when I give this conversation, folks will reply, hey, but I don't have big data. And there's a couple of things that I would challenge back to you on that, which is that we're at this point where the cloud is really interesting from the perspective of offering a way to aggregate all of the data that's coming out of your organization, whether that's in sensors, whether that's in the devices that people are using your apps on. It now provides a mechanism for us to collect all of that data. The second thing I would say is it doesn't have to be data that moves to the cloud. As we deploy apps into the cloud, a lot more data is going to be born in the cloud, and we can afford to keep it around. A lot of folks will look at, oh, I have this problem of I have petabytes and petabytes of data on-prem, and getting that moved into the cloud is a classic physics problem of a FedEx truck having more bandwidth. But as more apps are getting in the cloud, we're going to generate more and more data there that we don't have to throw away. And as the cost of storage goes down, it seems to be going down every week, it gets harder and harder for us to not keep that data around, right? Because it's so cheap for us to keep it around, at some point in time, I will be able to ask an interesting question of that data. So now let's talk a little bit about the classes of usage that we see. These are really kind of the patterns that we see customers, the journey of customers going through. And the first is really around what I would say is exploratory analytics. And this is what I think a lot of folks think of as big data, which is, how do I have a hypothesis? How do I test that hypothesis? How do I ask a question of the system and refine the question in order to get to the right set of answers? And this is really independent of any number of domains. But I know that I'm collecting, for instance, in the HDInsight service, I know that we are collecting a ton of telemetry off of the Azure portal. And so what I'd like to know is, where are folks falling off of the path of when they go through the process to enable RDP? Right? And so I want to be able to formulate that question. I want to be able to ask that question and find out against that data store what's going on. And then what will happen as I find something valuable, if I find nothing valuable, then I have to go find another question to ask. But when I find something valuable, what I want to do is then take that and operationalize that. Right? I want to turn that into a dashboard. I want to turn that into a blinking light in somebody's office. I want to hook that into an alerting system so that when I cross a certain threshold, somebody's phone rings, either because it's good or it's bad. And then really the last step of that journey is, so I've found an insight. I'm now alerting on that. I'm monitoring that. What I'd actually like to do is incorporate that directly into my app. And so taking the output of that query, taking the output of that analysis, and landing that in some online store, right? And that could be a relational database, that could be a document database, it could be a cache, but it's something that's powering the app of my business. And the classic example I have of this is we've worked with an oil manufacturer, or an oil company. And if you can imagine, an oil rig has a lot of sensors on it. And all of those sensors emit a bunch of data, and they happen to have a whole lot of those rigs placed around. And so they started analyzing across a very large set of data failure rates among components. They didn't know exactly what they were looking for, and so they were trying to find various classifications or correlations between events happening. And what they started to stumble on was that wind chill was a leading indicator of a certain class of device failing. This was a little surprising for them. They had thought temperature or rain or wind, but wind chill was the one that was the most highly correlated. So they said, okay, well now let's incorporate that into our reports so that when the rig operator sits there, now he's got a blinking red light that says, be careful, this component may be failing because we've had N number of days of wind chill below some temperature. And then the final step of that would be getting the person who's, certainly the person still has to look at the dashboard to know that something could break, but really getting that out of the way and integrating that and say, hey, we've now had 4 days, let's just go file the help request to go replace this part, right? And so that's kind of this journey that folks tend to go on, independent of the type of question that they're asking or the problem that they're trying to solve. And when we see folks walk up to Hadoop, really a lot of times there's a ton of folks who are doing what I would say is they're just doing SQL just bigger and probably cheaper based on the price of storage and the fact you don't have to run the compute all the time. But they're not doing advanced machine learning. They're not doing any predictive analytics. They're simply taking advantage of the economics of the system. And they're being able to run these types of queries over data that they probably couldn't afford to put in a traditional data warehouse. If you think about the price per terabyte per year for a managed piece of data that sits inside of a data warehouse, it's pretty expensive. When you look at what it costs to put it in Blob Store, that's a very, very orders of magnitude difference there. But then they're going to start asking questions in a bit of a different way. They're going to start going beyond kind of the basic analytics. They're going to start moving into more of the machine learning, more of the predictive analytics, and that lands you with data really driving the business. And so the architecture diagram that we kind of have for this is that you've got this set of things that are generating signals. These could be servers, these could be pieces of hardware, these could be games, these could be cell phones, airplanes, airplane engines. All of these things are going to spit out a whole lot of data. You're going to want to ingest that and land it into Blob Store. That's ultimately going to be the place, it's the cheapest to keep it, and it's going to be the easiest to query it. And then you can spin up an HDInsight cluster on top of it, and for this pattern of experimenting, understanding the data, shaping it, and ultimately forming a query that I want to operationalize, you can move in this very nice virtuous cycle. And then you need to publish that data. And publishing that data could be as simple as, hey, I want to land it in an Excel notebook that folks open up, because that's what everybody in my org uses. It could be landing it inside of a database for other analytic workloads to go ahead and take advantage of downstream. Or it could be landing it in a database that's powering an app, where the output of that query is influencing the behavior of the app. So then folks are going to consume that, leverage it to make whatever they're doing better, and then this cycle repeats. And this is this kind of virtuous cycle that once you start down the path, can deliver a bunch of value. So now we'll flip over to tips and tricks. So the first thing I'd like to talk about is integration with the various pieces and parts of Windows Azure. And so let me flip over. The first thing I'm going to talk about is integration with blob storage. So I mentioned earlier HDInsight sits on top of blob store, but I want to show really what that means. And so here I'm looking inside of Cloud Explorer. I'm looking at a container called mwinkle build 24. This is the default file system for the Hadoop cluster that I've got up and running. And this folder structure is the projection of the file system that Hadoop sees. And so when I walk into the HDInsight cluster and I say whack, hive, blah, 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 that is bottoming out on these blobs. And I've got network connectivity, so I should not have clicked expand there. But this is the projection of the Hadoop file system into blob store. And what's super interesting about this is there's a lot of things that can talk to blob store. And they don't have to talk to blob store through Hadoop. And so anything that can talk to blob store can produce data for HDInsight to consume. And anything that can talk to blob store can consume data out of an HDInsight process. Because at the end of the day, it's just files sitting inside of blob store. You don't need to write in a custom format. You can just land your files here. And so let me just back up just a little bit there on the custom formats. Hadoop is incredibly extensible. And so if you have, a lot of the examples you'll see will be text files. Lots of comma-separated values, because lots of log files look that way. But if you have custom formats, it's fairly easy to plug those things in. And so we've talked with teams internal to Microsoft that have a binary memory dump off of a device that they're putting into blob store. And they want to be able to run a Hive query on top of that. Okay, there's a little bit of math we have to go do to figure that out, but that's certainly possible. And so really, that's where the power of blob store shines with HDInsight. So the next one is table storage. We'll be publishing a preview of a driver for table storage in the next week on GitHub. And what this will allow you to do is leverage Azure Table Storage as a data source. So if you're writing out log information or diagnostics information into table store, you'll be able to use that. And then I'd like to show integrating with Azure website logs and integrating also with SQL databases. And so for the first one, for website log processing, so I used to be on the Azure Websites team before I joined the HDInsight team. And one of the cool things that those guys did is that they've got a feature inside of the Azure portal that lets you turn on all of your HTTP logging and web app logging to land inside of blob store. And so you can walk up to the portal, go to your website and say, hey, I'd like to turn on this. I provide a storage account. This is the cool part about being on blob store, right? Because all it does is it writes into blob store. And so this is an example of a pig script for talking to the weblogs log files using pig. And you don't have to pay attention to a lot of the stuff in the middle there. The two things to call out are, I provide this file location up top, which is where I'm going to load from. And this is the container and the blob account that I provided when I enabled that logging for websites. Now, underneath that, the web logs are actually partitioned by year, month, day, hour. And so there's a 5-level hierarchy. The nice thing about pig is that you don't have to do anything in order to just grovel over that and traverse the entire directory. And so pig's an interesting language. It's a data flow language, and so what you see here is we're loading up all of the various columns. We're going to filter out the header rows, do a little bit of grouping, and then we're going to generate some results. The nice thing about this model of development is that I can build up a fairly long script. I don't have to just do one computation. And when I go to execute that, what it's going to do is the compiler is going to be smart enough to look at that graph of Hadoop jobs and not do rework, right? So if I have 20 different reports that I want to produce, I can just go through and have that all in one large pig workflow, and I will be more efficient than if I tried to go write all of those MapReduce jobs myself. Now, the next one that I want to show is Hive. And this one's pretty cool because a lot of folks get scared when you start showing them MapReduce, or nobody's seen a language that looks like pig. And they say, everybody knows SQL. And so that's the nice thing about Hive. Hive is just SQL on top of MapReduce. And so what we can do with Hive is we first declare an external table. And what that allows us to do is say, hey, there is this set of files sitting somewhere, and this is what they look like. That's all I have to say to Hive in order to be able to write queries against it. I can then go outside of that and load as much data in. Again, I'm just putting it into BlobStore. I'm never going through Hive to load the data. And I specify where is that location going to be. And you'll see here, this is the same place that I'm going to write that data out from Azure Websites. The nice thing is that there's been some extensions that have been done to Hive to go ahead and say, hey, I can skip the header row, for instance. And so this is where SQL folks will sometimes get a little, whoa, what's going on here? Because Hive is at times very logical. This is the structure. There's going to be some format. It's OK. This is what my table will look like. But then at other times, it flips to be very physical. And it will say, hey, these files are going to sit here. They're going to be delimited this way. That gives you all of the flexibility of Hive, but it does make the programming model a little harder. But it gives you some nice things to be able to say, OK, I have a laser. Cool. That I can walk up and skip all of the header lines on these multiple, tens of gigabytes of text files. So I don't have to worry about cleaning them up or anything like that. Now, normally, up until about 4 or 5 months ago, if you wanted to do this scenario with Hive, it didn't really work really well. Because Hive wouldn't honor the file hierarchy. You had to be very explicit with Hive and say, no, I've got partitions. And the problem is, if you've got something that's partitioned down to the hour, or we've had a team internally partitioned down to the minute, you have to start getting very explicit about adding lots and lots of partitions. And so in this case, 2 things have been added here, which is really being able to say, hey, I'm going to recurse these, and please Hive honor subdirectories. And what this lets me do is then execute a query that looks just like SQL against website logs. And I can schedule that to run every day and just get updated numbers and output them. And so this is pretty cool. This lets me turn on logging from Azure Websites and then write SQL on the behavior of my customers hitting the website, which is kind of neat. So next we'll talk about interacting with SQL databases. This is not specific to Azure SQL databases. You could replace this with SQL running in IaaS. You could replace it with MySQL, Oracle, really anything that you've got up and running. You could do that, but I use SQLDB as the lens here. So the first thing to point out is Scoop. So Scoop is an Apache project that's all about moving data into or out of relational stores and into something Hadoop understands. And so what I'm doing here is I am importing from Azure SQL Database into Hive. And so all I really do here is I form up this JDBC connection string that takes in my server name, credentials, which are omitted here, and then what table I would like to pull from. The only kind of gotcha to call out here is this kind of goofy, I'll stop using the laser, it's not showing up. This kind of goofy syntax you have to use on the command line. This is one of the things with Hadoop is that everything's just a little different sometimes. And so in order to pass in the schema for the database table that I'm calling in, I have to first put in these two just random dashes. That will get you. If I want to, and so that's the command I'd run if I was sitting on the head node RDP'd in. If I want to submit that via PowerShell, there's a first-class way to do that via new Azure HDInsight scoop job definition. Right now, the commandlet doesn't do a lot more than take in this string. You can imagine that getting fixed over time so that you would just point into what table you'd like to pull in, and we'll take care of all of that for you. So the other thing that we could do is that we could store into SQL databases from PIG. And so a number of the Hadoop projects, PIG is one of them, the cascading and scalding ecosystem is the other one, has started to build up a library of adapters that can talk to a number of systems. And so here what we're using is a PIG storage mechanism that can talk to databases via JDBC. And so I would write that PIG script that I showed earlier. I have to do two things up front. I have to register a couple of jars. And so these can be jars that either live on the system, which is the case for these guys, or you can actually just point to a jar that sits inside of blob storage. And I'll show an example of that in just a sec. And then I'm going to use org Apache Pig Piggy Bank storage DB storage, again, configured with that JDBC connection string. And so what this lets me do is have a pig query. You can imagine I use pig to clean up a whole lot of logs. And I do pig to do data cleansing, I clean some things up, and I write that out for further analysis. But I also want to write a much smaller set of data as the summary statistics that I want displayed in my web dashboard. This would be a case where you could then just take that, filter down to the top 100 rows, top 10,000 rows, and using DB storage, pop that over into SQL. So then there's all of the components that are popping up every day inside the Hadoop ecosystem. And we've got a set of components that are contained on the HDInsight clusters. There's a set of components that are not. And really, the story, these fall into two camps. There's a set of things which are really libraries. These are just things that help you write Hadoop jobs better. Mahout, scalding, cascading, Scooby. And the story for these is you can go ahead and submit these and they work. You can either submit them remotely via the PowerShell, because most of them can be submitted as a MapReduce job. Cascading and scalding are both that way. They'll produce what's known as a fat jar, which you just reference that jar when you submit the MapReduce job, and it'll take off and it'll go and run. Or you can submit it on the command line. Couple of things that we've seen for some of these projects, a lot of these just work. We've seen that some of the projects, when they're compiled into those fat jars, which is useful because it'll pull in the scalding libraries that are required, for instance. The Hadoop bits that it pulls into that jar don't contain the Azure storage driver. And so that's something we're fixing because the storage driver is getting checked into Apache, so that will eventually be in those jars that it pulls. And it's also something that we're fixing in some cases by working with the individual projects to say, hey, here's a patch that fixes that. The next set of things are really not libraries, they're services. And these are things like HBase or Storm or Accumulo. And right now, there's not a good mechanism to deploy those to the cluster. I'll just leave the ... there and hope I get invited back to this conference at some point in time to talk to you about that. So an example for calling Mahout. So this is the PowerShell syntax that you'd use. And really what you're doing here is you can kind of squint and see the Hadoop command line that you type in. You type in Hadoop jar, point to the jar. Now the interesting thing here is that this is just a jar that's sitting out inside my blob store account. Right? And so I can update that independent of having, I don't have to push bits onto my cluster. As long as I can get them into blob store, I'm fine. Then I'm specifying, so that's the jar file I'm going to run. What's the class? So I'm going to use the Mahout driver. When you use Mahout driver, the next input on the command line will be what class you want to use to run the job. So we'll run this clustering algorithm, and then we'll pass in a bunch of config parameters, which if you understand Mahout, all of these config parameters make a whole bunch of sense. But if we do this, this is going to turn around, and this will then execute that clustering algorithm as a MapReduce job. So let's talk about leveraging other runtimes. Because not everybody wants to write Java, and that's OK. Hadoop kind of recognized that early on, and so they built an extensibility mechanism in known as streaming. Streaming is the most confusingly named thing in the Hadoop ecosystem, and that says something, because it has nothing to do with stream processing or streaming analytics like Storm or Kafka or any of that stuff. But it's an extensibility point that allows you to write a MapReduce job with any executable. And the communication contract is standard in and standard out. So it streams data in from the console and out from the console. And so as long as you can write something that can read from standard in, which is anything, you can actually write Hadoop jobs using that runtime. This then pops up as well in Pig and Hive. Both of them will allow you to essentially use a streaming UDF, where you can provide your own runtime. So what other runtimes can we leverage? So .NET 4.5 is available on the clusters as of later today, or early tomorrow, but it should be later today. Python is available on the clusters as well. Other runtimes, I'll show you how to do them. They're not there, but you can get them there fairly easily. If folks are particularly passionate about another runtime, Ruby, Node, et cetera, please shoot me mail. We're trying to prioritize what other ones we let folks put down on the cluster. So let's look at other runtimes. So we'll start off. First, we will show two different things here, which are on the left-hand side is a UDF to be called from Hive, written in Python. And on the right-hand side, we will use R in order to write a MapReduce program. And so I am neither a Python nor R expert, so I will not even attempt to explain what's going on here. But the important thing to see here is, again, the programming model for Hadoop extensibility here is standard in, write out, read in. And so that's incredibly flexible. There's a little bit of wonkiness when you look at some of these loops to make sure that you actually exit the loop. And so the first time you write one of these, you'll probably shoot yourself in the foot. Just because you have to keep a little bit of state around, particularly on the reducer. But this you can build. The cool thing about this is you can run this locally and test this, right? Because all I have to do is pipe in the text file that I'd like to test this on. So there's a great debugging experience. So let's look at what it means to use these. And so the first one from Hive is about adding a file. So Hive has two different things. It has add jar and add file. And what either one of these will do is essentially pull that file in so it can be referenced by the job. In the case of a jar, it'll just get added to the class path. In the case of this, it will end up, when I use the transform function in Hive, this basically, you should read this as go ahead and shell out to something, and I will use standard in to pump all the data in and then retrieve the data. And so what we're doing here, you do have to provide the path to the Python exe. We'll probably fix that over time, so we just register the file extension. But I just point python.exe at that file that I brought in, and now the data that comes in will get transformed. And if we go back to this, all this is doing is it's reading it in, it's spitting out most of the information separated by space, and it's adding an MD5 hash of the telephone number. And so this is where we're leveraging Python to say, I want to write a better Hive query. In the case of R, we have to be a little more fancy. We have to take advantage of something which is the archives parameter, which allows us to pass a jar file that will be expanded into the working directory. And so this is cool. This is how we can smuggle any runtime in. Anything that can be bin copied deployed can follow this pattern. And so Perl, Ruby, any of those things, you just have to wrap it up in a zip file, rename it to jar, and pass it in via archives. And then what's important to note is when I pass in archives r.jar, that will get unzipped into the working directory in a directory that is the name of the jar file. And so as long as you program relative to that, which is what I'm doing here, current directory, rjar bin, rscript on mapper.r, now I can run R. And so if I've got any libraries in R, if I want to use that, rock on, you can go ahead and do that. A little bit of a note here, just again, take that directory, zip it up, rename it to jar, and then pass that in. So I'd like to wrap up by talking about moving data between stores. So we talked about Scoop already in the context of moving in and out of Azure databases. Pig, Hive, and Cascading all have varying different adapter layers. It would be great if all of these came along and unified so that there was a single set of taps that you could use. But right now they're kind of on a per project basis. I'll go and I'll show a couple of examples of this. The one thing that I want to call out here is that Hadoop can be a very effective denial of service tool. If you have a 500 node cluster and you point it at your single instance running on a small VM of Mongo because you're playing around with it, bad things will likely happen. And so that's just something to be aware of. Hadoop doesn't have a notion of kind of aggregate throttling across the cluster, and so it can be a very large cannon. Be careful where you point it. So let's talk about integrating with Mongo. And so background on this, I've got a Linux VM running up in Azure that I've installed Mongo on. I want to call this from Pig. There is a Mongo Hadoop project that's available from the Mongo folks. You grab that from GitHub, you build it or grab the binaries, put those jars inside of Azure Storage, and then just like with Hive where you could add the jar, here we're going to register these jars. And again, that basically pulls those in and says, hey, these functions are now in your class path. And then when I get down to store, again, I'll write a pig query, and I will store into this URL that's a Mongo. It first points to what is the machine running it, what's the port, and then what's the database and collection. And what do I want to do? I want to use the Mongo insert storage. The Mongo guys have built both a storage layer and a loader, so you could go both ways. And what this looks like when it's all said and done, ignore the first one because that I just had to put in there to get the collection created. But this is that same query that I ran earlier, computing a bunch of statistics on my website of what is the URI stem, so blog post, link to SQL, number of requests. All of that data is now in Mongo. And so this plays to this pattern of leverage the tool that makes the most sense. Hadoop is not an interactive query tool. I won't stand up here and make that claim in any way, shape, or form. Mongo is great for that. It's a great back-end database for a website. So use Hadoop for what it's good at, running all these analytics, and then get it over into Mongo so that you can pull it from your website. Let's look at this from Hive as well. Again, we follow that same pattern. We're going to register a number of the jar files. This is where the DDL gets a little crazy. I'm going to pass in Serde properties. I'm going to talk about the mapping of column names, of entity names from Mongo to column names in Hive. So that gets a little messy there. But once I do that, I can go ahead and just write Hive queries against it. Cool thing about this, I could join this, right? I could take data that lives in Mongo and join it with data that lives in Blobstore with data that lives somewhere else where I can pull data from. So that's kind of cool. So let's talk a little bit about this transient cluster pattern. This really hinges on all of your cluster basically being stateless and all of the important information being stored outside the cluster. We take care of that for you with Blobstore. When you go down the custom create route, you can take care of that for the metadata that lives inside for Hive or Uzi. And then the final thing that I want to talk about on this is you also don't have to know up front for your cluster what are the storage accounts and metadata stores that I need. I can pass those in at runtime. And so the way this looks is this is the PowerShell to do this. And this is just providing your storage account name and key and your database connection info when you submit a job. And so what this means is that my cluster doesn't have to know anything about this storage account or this database, but for the scope of this job, those will be available to it. And so this really allows me to, on a per-job basis, attach what storage do you want to use. One thing to note about this, again, to not shoot yourself in the foot, at cluster provisioning time, we prevent you from binding to a storage account that lives in a different data center. Two things are not on your site in that case. One is physics, and the second is economics, because you're charged for egress from a data center, and so if you pull a terabyte of data out of the data center, that will show up in 20 to 30 days on your bill, and you may not be pleased about that. This mechanism does not have that check. Don't shoot yourself in the foot, but that's just one thing to note about this. So really, what are the next steps? I'd like to thank everybody for coming today. If you've got an app that's running in Azure, start landing your data in Azure Storage. Please just do that. If you take nothing else away from this talk, just take that away and put the data there. Because at some point in time, you'll want to ask a question of that data. We worked with a customer who was uploading all of their log files from all of their on-prem servers into Azure for years. They didn't know what they were going to do with it. They just wanted a cheap backup solution, and so that's what they wrote, and it was doing that. Well, at some point in time, they had a competitor come along and file a lawsuit against them. And they were able to definitively defeat the claim against them because they were able to take this multi-tens of terabyte corpus of log files and run some interesting queries over it that essentially disproved the claim that was being made. So please, land data in Azure Storage. If you've got an Azure account, well, if you don't have an Azure account, please get one. But once you get that one, go ahead and take a cluster for a spin. And this ecosystem is so vibrant and exciting and moving fast. Every couple of weeks, there's another project that comes along, which is somebody's doing something cool. And so this is a really nice way to get in, to start playing around in that ecosystem, and to start getting knowledge out of the data that you've got in the system. So I'd like to thank everybody for coming. I really, really appreciate it. I think there is a feedback link at the end of this. I certainly welcome feedback. Please let me know how I did and what I can do better. I'd like to turn it around and ask and open it for questions.
Two questions, actually.
Okay.
One is, can we expect quicker deployment times for the clusters?
So, yes.
The 10 minutes?
What would you like it to be?
Well.
What do I have to get it to? To get you in this brand new automobile, what do I have to get it to?
Well, some of the tools that we're evaluating, they're meant for kind of on-demand processing.
Okay.
They're more front-end tools for on-demand processing using Hadoop services. So having 10 minutes really is not a good user experience. So 5 minutes or less, maybe.
Okay. All right. Everybody heard him say 5 minutes.
Or less.
Okay. Second question?
The second question was, again, going back to, like you said, the ecosystem. Some tools are really meant to go against the data node or name nodes and task trackers and so on. Is there any possibility in the future of being able to deploy the clusters into a virtual network?
There is a possibility of that.
A good possibility? Or?
There's a possibility that does not have a time frame associated with it.
Okay. But it's on the...
But it is a possibility that has been discussed.
Okay.
Okay. I don't think there's a marketing guy in the room, so he won't yell at me for that. So. But yeah, no, that pattern of integrating into virtual networks is something we're seeing more and more folks look at, and so it's on our list. Mm-hmm.
That's where MapReduce theory looks really very interesting because as a geoscientist or science,
Mm-hmm.
could run the model for a dot, okay, CRR.
Yeah.
And other than three, which is and everything, strings and then back, odd. So is there any possibility at all down the road for tight integration with .NET?
Yeah, so right now we've got, so the question is, I've got a bunch of folks who are familiar with .NET. And certainly as the Microsoft employee in the room, I don't want to be the guy to say, hey, don't do .NET, go run and install Java. That's not what I'm saying at all. You know, we've got a set of things that integrate now today. One is we've got a MapReduce library. It's in NuGet. You can pull that down. That'll let you write MapReduce jobs. And if you can get over the kind of architectural bad taste in your mouth of streaming, we've got a number of folks who are using that and are successful with it. Certainly, you look at the streaming thing and it feels funny, and there's some additional perf issues because you're marshaling basically twice. But what we've seen with folks is that they're okay with the perf impact that they get with streaming because they're more productive with .NET, and so they'll just buy more boxes, you know, or turn the dial up on how big of a cluster. Yarn is something interesting in terms of opening up that space a little bit more. I don't think it's outside the realm of possibility to see much tighter integration or a really first-class .NET application master. So, yeah, what about Thrift? So the Apache Thrift project has a C# generator. We've actually got a NuGet package we'll be putting out in the next week or so that's an Avro package. We've seen more customer momentum around Avro as a serialization format than Thrift. It's a bit of a religious thing. You've got the Protobuf folks and the Avro folks, and inside of Microsoft, we've got 2 or 3 ones that people have built that are just internal things. But Avro is the one we've seen the most right now. Other questions?
Is there any to like per execution plan to understand how high work is split in terms of jobs?
Yeah, so there's actually a series for both Hive and Pig mechanisms to walk up and say, hey, describe the query plan, basically. I'm going to completely blank. I think in both cases it's describe, and then there's another more verbose one, which will actually completely generate the query plan for you. You have to squint at it a bunch. It's all text. And it's ultimately about a graph of MapReduce jobs. But once you kind of figure out what's going on there, you know, rock on. But you can get both of those. They're just parts of the language.
Because it's not deterministic to know how much time per it takes.
Correct.
There's no way to do that.
There is no good way to do that. Like a lot of perf things, it depends. And there's a lot of variables. You know, when you're then running in Hadoop, you've also got the additional variable of things may fail more often. When you've got 500 machines, will one of them die? Probably at some point over 6 months of running. How will that impact your latency and those types of things?
Because if you manage the MapReduce code, the lower part of the code, you probably know how much time it takes. You can imagine, you can calculate.
Yeah.
If you were high, you can't know
Yeah.
how time is split in the
Yeah, I would say that the sophistication of the metadata, the statistics, and kind of all of the things that you'd kind of walk out of a database class thinking is kind of like, hey, this is a query processor, query optimizer 101. There's a lot of those things that are still just getting introduced now. Part of the Stinger effort that we've been working on with Hive is we've got so the HDInsight team sits inside of the SQL team at Microsoft. So we happen to have a bunch of folks who can do what you just described in their sleep. And we're bringing a chunk of that into Hive to try and make that better. Any questions from this side of the room? Sorry, I want to give this side a chance.
Yeah, you mentioned this a little bit earlier about being able to do workflows and automating the jobs. So we have a bunch of streaming jobs using the HDInsight, NuGet packages and so on. and we want to run that like every 15 minutes to be able to process log files and blob storage. How
Okay.
do you guys recommend managing that in Azure and being able to automate those jobs all the time and then make that happen?
So come talk to me afterwards. I'd like to dive a little bit more deeper into that. But the, right now, almost everybody does something very similar to that. Sometimes it's 5 minutes, sometimes it's an hour, sometimes it's a day, sometimes it's 15 minutes. There are two different things to think about. One is something known as Uzi. So Uzi allows you to orchestrate a set of jobs and schedule them. The downside to Uzi is that it's tied to the lifetime of the cluster. So if you want to turn your cluster off for some point in time, Uzi lives in the cluster, so it can't wake the cluster up and say, hey, go. So we see a lot of folks start with Uzi, but then move to scripting outside the cluster, using something like PowerShell, using something like even just writing code directly against the REST APIs, and then taking that and scheduling that. The options that you've got in Azure that I've seen, running a very small node, just a VM that's using Windows Scheduler. That's the most naive implementation, but it gets it done. The next step up that would be integrating with Azure Scheduler. So Azure Scheduler is a service that you can go and say, hey, every 15 minutes, ping this endpoint. You'd have to connect the dots to say, okay, let me catch that on the other side in an Azure website and kick off that workflow. The nice thing about getting it external to the cluster is that you actually don't ever have to have a cluster running at that point. Because you can just say, hey, every hour, every 15 minutes, spin up the cluster and go. This gets back to your point about, hey, 10 minutes, if you're trying to do it every 15 minutes, it probably makes sense to keep it up and running. But as we get that number smaller, it becomes more interesting to do that. But for we have folks who do that now who are doing the every hour scenario. Okay, last question, and then I think I'll get kicked out of here.
How big is your typical cluster that your clients use? I tried to kick off a 20-node cluster, and it took about 10, 11 days before the team came back and said you can have it.
Okay.
I'm just wondering,
So yeah,
is this going to be
first, that's a bug, and I apologize. And I'd like to talk to you because I want to find out exactly what happened there, because it shouldn't take that long. So like any Azure service or any other cloud service, we've got a set of quotas in place out of the gate. And so our general turnaround time for changing quota, you should just file the support request, and it should take less than 24 hours. And so I want to follow up and find out what broke there, because that shouldn't have happened, and I'm sorry about that. We see a mix. For the set of folks who have operationalized workloads, we're seeing in the hundreds. We're seeing a number of them that are sub-100, but certainly more than the 20 or 30. And then we see a lot of, there's a lot of folks who are getting a 4-node cluster and doing dev work. But in terms of the set of folks we've got who are running more operationalized workloads, we will be more than happy to give you as big of a cluster as you'd like. There are just certain thresholds where we have to ask a couple more questions. We also don't want that in the drop down, and then, that could be an unpleasant surprise. So, anything else? Okay, if not, I'll be hanging out back there. I'd like to thank everybody for coming and enjoy the rest of Build.